One, two. Check, one, two. Check, one, two. Good evening. This is VK3 Echo Kilo Hotel, VK3 EKH, the official station of the Astronomical Society of Victoria, with the regular Friday night broadcast coming to you from the studios of VK3 CSJ in Narre Warren South on this 20th of October. A very pleasant good evening to all folks that have tuned in tonight to listen to my dulcet tones once again. Trust everybody is in good health and doing the best they can on a reasonably balmy Friday night. We're broadcasting on prime frequency 3541 kilohertz in the 80 metre amateur radio band and via the Melbourne television repeater, TV repeater, ATV repeater, VK3RTV, digital channel 1. Very pleasant good evening to viewers there. We're also streaming on my YouTube channel, if you can call it that, VK3CSJ. So just type in VK3CSJ in the YouTube search engine and you should locate the channel and just look for the live symbol. This is VK3EKH broadcasting on 3541. And just checking my levels. 1, 2, 1, 2, 1, 2. I hope that's okay. Probably a little bit more level on the YouTube side of things too. 1, 2, 1, 2, 1, 2, 1, 2, 4. Audio, as the Americans like to go. Anyway, very pleasant good evening to everybody, and trust all's well. As an update on my dome story, the dome arrived on Wednesday morning. Wednesday was probably one of the best days of this week, weather-wise. I took the day off from work to meet the truck driver, and I had the day, in fact Monday, I had a fairly large truck deliver a lot of crushed gravel. The soil out the side here had been pretty muddy due to recent weather, but there was a 50 metre trench dug for power and data cable to where the dome is going to go, and that ground is still a little uneven and soft, and because of recent rain, it had become quite messy and muddy. And I knew the dome was coming this Wednesday this week. So I went and got some gravel, and I've been busily shoveling about 12 cubic metres of crushed gravel around the yard. Lots of hard work that is, I've got to tell you. But this truck that came in was a monster truck. I half expected a very small mini tip truck to arrive, but it It was a huge truck which barely made it down the driveway, and when it decided to do a 3-point turn in the driveway to align itself back up to the driveway to disappear, it really ripped up the ground well and truly. The driver said, "Sorry about that." Anyway, as soon as that truck left, I had to get the shovel and try and smooth everything down. It was all just a muddy mess, and I knew that this was not going to fix itself by Wednesday. And it sort of did, but it was still pretty soft underfoot. So this truck that delivered the dome was a crane truck. It had a crane on it, and the driver said to me, I can't come down this driveway going forwards. The best way for me to do it is come down the driveway reverse. The driveway here is a little bit, there's a kind of an S-bend. It's not much of an S-bend, but there's a little bit of an S-bend which happens to go downhill a little bit too. So the driver had to negotiate a bit of a turn in the driveway as he tried to align up to come down to where to unload this dome. So it was a bit of an interesting story. I've got a little bit of video footage of it, not to show tonight. I haven't quite got it all edited together yet, but I will soon. Anyway, the dome's arrived. Short story, long. It's sitting in its marked spot, and we're just waiting now for the installation team to come and to install the dome, which is pretty much all ready for now. So looking forward to that. And then, of course, the next trick is to install some telescopes, or a telescope, one at a time, and get a bit of a feel for doing optical astronomy. So yeah, it's almost happening. After all these years, I've been wanting this 3-meter scope dome for a long time, and it's kind of been finally come to fruition. There it is. It's an update, and I'm sure you're bored to tears. Anyway, the Astronomical Society was founded in 1922 and comprises well over 1,600 members scattered about the state and the country and overseas. Membership of the Society is open to all persons with an interest in astronomy. The Society's objectives are to encourage the study and practice of astronomy, and to disseminate the knowledge of the science, and to provide greater facilities for the study among its members. Monthly meetings are usually held on the second Wednesday of each month, except in January, with the latter being held on a Saturday night. Meetings start at 8 p.m. Maulia Hall, Burwood Avenue, Melbourne, near the Melbourne Observatory, which is located adjacent to the Shrine of Remembrance. Parking is available in Burwood Avenue, Dallas Brooks Drive, and surrounding streets. Admission is free, and visitors are most welcome. These meetings are also now being televised on the ASV's YouTube channel, and I think it's also on a Zoom format. Privileges of membership include the right to borrow books, periodicals and other publications from the Society's extensive library located at Melbourne Observatory, copies of the ASV magazine Crux containing articles, news, observing notes and the like, and the free provision of the Astronomical yearbook. Access is available to telescopes on members' nights held regularly at the Melbourne Observatory and after monthly meetings, weather permitting. These instruments include the Society's 300mm equatorial reflector and a 300mm portable reflector. There's also a 200mm refractor managed by the Royal Botanic Gardens, and a photoheliograph also housed in the observatory and is accessible to members as well. The Society also has a number of 200mm reflectors available for a short period loan on the telephone loan scheme that ASV conducts. Members are also encouraged to make use of the Society's country property located near Heathcote, some 90-minute drive north of Melbourne. There are a range of instruments available for members to use, the larger two only with appropriate training, and these range from 300mm to 1000mm in aperture. There's also located on the site is an 8.5 fully steerable radio telescope which members can access with involvement to the radio astronomy section. Members are encouraged to make and use telescopes. Advice and help on both matters are provided willingly to newcomers desiring to do the same thing. Instrument making is only one of the number of common interest activities catered for within the Society. Other areas of interest that members can participate in include deep sky observing, astrophotography, lunar and planetary observing, auroral, meteor, comet and radio astronomy, computing, cosmology and astrophysics. Historical studies and research and astronomy in general are all catered for. There are actually 22 sections that make up the ASV. Keep forgetting that figure. Contact details for various section directors are provided in the yearbook, but if you don't have the yearbook, and of course you can only get the book if you become a member, but all that other information can be found on the ASV website at www.asv.org.au. That's www.asv.org.au. All can be found there. Further information may be obtained by visiting the ASV website, and notifications of events are given in Crux Extra Bulletins, which is an email format, and emailed to members every other week or so. Please note that the ASV will conform to all government health directives. ASV events may be required to be cancelled, moved or postponed, all depending on what the circumstances are at the time. If you wish to write to the ASV, the Secretary, write to the Secretary, Astronomical Society Victoria, GPO Box 1059, Melbourne, Victoria 3001. But like I say, just visit the website at www.asv.org.au and all will be revealed. You're tuned to ASV Radio, VK3EKH, coming to you from the studios of VK3CSJ. We also have an email address, which I forgot to mention, vk3ekh@gmail.com, vk3ekh@gmail.com, and I'm looking at the inbox as we speak. G'day Wayne, and Andrew and Steban. Thanks Wayne for the article. It's all queued up. Actually not that particular one, but one similar to it. So we've got that ready to go if I don't run out of time. We have a update solar report from our space weather woman, Tamitha Scove, tonight, and she's on there for 15 minutes. She's actually got a nice long report tonight. So I'm going to try and time my reports, my articles here to finish at about 1:45, and we'll cross to Tamitha. So it's just a few hours old. See what she has to say. Okay. What was the other thing? There's something else. Oh yeah, and the Discord channel. If you've got Discord, installed, just look for the astronomy chat room. I think that's the appropriate term to use if you're going to look for it. Is it, Richard? I'm still not sure. Our ASV website, for some reason, is not quite up to date at this stage. The old radio astronomy page, where all my links were for tonight's broadcast and stuff, have still not been repaired, still not been restored. I'm not really sure why. But I'd normally point everybody. I would normally point to the radio astronomy page on the ASV homepage. But things haven't. I don't know why it's been taking so long for that to be updated. So I'm not sure how to point you guys. If you want to come up on Discord, I'm not too certain how that works. Other than install Discord, get it installed as an app or whatever it might be, and then search for Astronomy Chat Room. I think that's what it's called. But a lot of folks find it. They're all there. I can see that they're all there. G'day Martin, Steve, Dave from the MBO, Mount Burnett. G'day Bill and Kim, VK5FUSE, over there in good old Australia, South Australia. And there might be a few other folks that are listening on there too, I think. Going by the other stuff I can see on the side there. Anyways, good evening to all. Trust everybody is well. I've said that already. Okay, let me see. What is the first thing I have here tonight to mention, to read out? If I can get my mouse in the right part of the place to look for. Oh yes, okay, courtesy of astronomy.com. Let me see, was there any picture for this? I don't think so. There was no picture for this. It's just an article, not very long, just something to kick off on. Okay, what it means for planets to align. Everything you need to know about when planets appear close together in the sky from our perspective on Earth. October 19, 2023. When we look up at the night sky, the dance of planets is a constant mesmerizing ballet. And occasionally this dance creates patterns that spark both wonder and curiosity, as is the case when planets come up in some sort of alignment. For centuries, the sight of multiple planets appearing close together in the night sky has fueled myths, legends, and prophecies. But what does it truly mean, astronomically speaking, when the planets align? And when can we expect to see the planets align next? So what does planetary alignment mean? First, let's clear up a common misconception. When we talk about planetary alignment, we're not suggesting that the planets line up in a perfectly straight line in space. Rather, we are usually referring to a celestial event wherein multiple planets appear close together in the sky from our perspective on Earth. And this phenomenon is known as a conjunction. The alignments we see from Earth are based on our line of sight. For instance, even if Mars and Venus appear close in the sky, they might still be separated by millions of miles in space. It's like standing on a hill and seeing two distant trees appear close together, even if they are far apart on the landscape. So why do planetary alignments happen? The planets orbit the Sun at different speeds and distances. This means they are frequently moving relative to each other in our night sky. Occasionally their paths will seem to cross, leading to an alignment or conjunction. For example, Jupiter takes about 12 years to orbit the Sun, while Mars takes about 2 years. The difference in orbital periods means that every so often Mars and Jupiter are positioned in a way that they appear right next to each other in our sky, creating a temporary alignment. However, because the solar system's planets don't all perfectly orbit the Sun in the same plane, it's relatively rare for more than 2 planets to align at once, although it does happen. So, what do planetary alignments mean for astronomers? Planetary conjunctions aren't just beautiful events for stargazers, they have practical implications too. For instance, conjunctions can serve as key reference points for calibrating astronomical instruments. And when planets do truly align in 3D space, exploration missions, particularly those that involve flybys of gravitational assists, might also leverage their positions. For example, NASA's Voyager 2 mission took advantage of a rare planetary alignment of 4 outer planets during the late 1970s and 1980s. Such an alignment, which only occurs about every 175 years, allowed the mission to efficiently explore the outer reaches of the solar system. So when will the planets line again, you might ask? Although conjunctions between 2 planets are relatively common, given the different orbital periods of each planet, full alignments where many planets all seem to close together at once are very rare. In the near future, on January 27, 2024, Mars, Venus and Mercury will all align in the morning sky. But one of the most awaited alignments will occur in the 2040s. Hopefully I'll still be around for that. This event will showcase Mercury, Venus, Mars, Jupiter and Saturn, which will all be visible within a small segment of the sky next to a thin crescent moon. Now that'll be a photographic choice. 2040s. I should be still around. So anyway, we've got a conjunction occurring January 27 next year. Mars, Venus and Mercury will all align in the morning sky. The historical impact of planetary alignments. Historically, planetary alignments have held immense significance for a variety of civilizations. Ancient cultures often associate these celestial events with prophecies, omens, or significant earthly occurrences. While today we understand the scientific reasons behind these alignments, looking back provides a fascinating perspective on human culture and our intrinsic connection with the cosmos. Boy, can we learn something in some places in this world. The Mayans, for instance, were keen and known astronomers. They very, very carefully tracked the movements of the planets and their calendar system interwove planetary cycles. Eclipses and alignments were deemed powerful enough to influence terrestrial events, warranting careful observation and record keeping. Similarly, the Babylonians, known for their detailed astronomical diaries, documented the conjunctions. And these records provided modern scientists with a treasure trove of historical astronomical data, including a cuneiform description of a massing of planets in BC 185. A cuneiform, C-U-N-E-I-F-O-R-M, that's a new word for me. A cuneiform, I think I'm pronouncing that right. A cuneiform description of a massing of planets in the year BC 185. On March 25 of that year, Mercury, Venus, Mars, Jupiter and Saturn all shared a small portion of the sky. In early Europe, meanwhile, the appearance of multiple planets in the night sky was often seen through a dual lens, scientific curiosity and divine interpretation. Great minds like Tycho Brahe and Johannes Kepler observed and studied these phenomena, and very carefully tracking the planets' positions to help better understand their motion. By recognizing our ancestral fascination with the cosmos, we not only gain insight into our past, but also foster a deep appreciation for the astronomical events that continue to captivate us. Planetary alignments and conjunctions serve as beautiful reminders of the dynamic and ever-evolving nature of our solar system. They bridge the gap between ancient observers who gazed upward in wonder and today's technology-empowered astronomers who seek to gain a glimpse into the mysteries of the universe. Amen. You're tuned to ASV Radio, VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria. Very pleasant good evening to everybody. G'day Richard, Mr. VRS, who's joined the chat window. No further emails up there on the email inbox. At 10:22 past the hour. Record-breaking radio burst could help us find the universe's missing matter. 16 hours ago published. Space.com. The 8 billion-year-old blast is the most ancient and distant rapid burst of radio waves ever seen originating from colliding galaxies. It almost seems weekly There's something amazing coming from fast radio bursts. There's a illustration here that I can bring up and show you on the screen on the picture. Let me see if I can bring my little insert up. There it is. Oh, look at that. There's my visual insert. I'll just reposition this camera so it's a bit better positioned on me here. Yeah, that'll do. Alright, back to the article. I might not read all of this. I don't know. It depends on how I feel. If I fall asleep halfway through, I won't read it all. Okay, so yes, it's working. An 8 billion year old rapid burst of radio waves stemming from ancient colliding galaxies could help astronomers solve the mystery of our universe's missing matter. The record-breaking fast radio burst, FRB, which is the oldest and most distant example of its kind ever spotted, demonstrates that scientists can use these emissions to effectively weigh the universe. FRBs are pulses of radio waves that are often last for mere milliseconds and are a puzzle to themselves because their origins remain a mystery. But the fact that this record-breaking example of one came from a group of 2 or 3 merging galaxies could help clear up mystery. The burst, designated as FRB 2022-0610A, was spotted by the Australian Square Kilometre Array Pathfinder, ASCAP, an array of radio telescopes located in Western Australia. In just milliseconds, the FRB appeared to release as much energy as the Sun puts out in 30 years. Using ASCAP's array of dishes, we were able to determine precisely where the burst came from. Research lead author at Macquarie University researcher Stuart Ryder said in a statement, "When we used the European Southern Observatory, ESO, Very Large Telescope, VLT, in Chile, to search for the source galaxy, finding it to be older and further away than any other FRB source found to date, and likely within a small group of merging galaxies." So where is the universe's missing matter, you might ask? From simulating the universe, starting at the Big Bang and ending in modern times, scientists have learned that half of all matter that should be present in the universe today is effectively missing. And no, the missing matter isn't dark matter, a form of matter invisible to us due to its lack of interaction with light. It's believed to be ordinary matter, made up of atoms that are composed of protons and neutrons, particles called baryons. For decades, this missing matter has evaded detection with the largest and the most sophisticated telescopes, but recently that's been traced to a vast void of space between some galaxies. The problem, however, is this matter is so sparsely distributed that it is equivalent to no more than 2 atoms existing in a standard-sized office room here on Earth. If we count up the amount of normal matter in the universe, the atoms that we are all made of, we find that more than half of what should be there today is missing. Team member at Swinburne University of Technology Associate Professor Ryan Shannon said, "We think that the missing matter is hiding in the space between the galaxies, but it may just be so hot and diffuse that it's impossible to see using normal techniques." Since the early 2020s, scientists, including the late Australian astronomer John Perry J.P. Marquardt, have begun to speculate that FRBs could be used as cosmic weighing stations to detect this nebulous matter. Fast radio bursts sense this ionized material, Shannon added. Even in space, this is nearly perfectly empty. They can see all the electrons that allows us to measure how much stuff is between the galaxies. And this is possible due to the fact that FRBs travel across millions or billions of light years. Their radiation is dispersed by this missing matter. And that means measuring the distances to as few as 6 FRBs could help determine the density of the universe. And this could ultimately help us locate its missing baryonic matter. There's just a little bit more to this. JP showed that the further away a fast radio burst is, the more diffuse gas it reveals between the galaxies, he said. This is now known as the Marquardt relation. It's just one Marquardt. Some recent fast radio bursts appear to break this relationship. Our measurements confirm that Marquardt's relation holds out due to beyond half the known universe. At the moment, around 50 FRBs have been tracked back to their sources, with the scientists behind this research suggesting that astronomers should be able to detect thousands of them across the sky, many at even greater distances. ASCAP is responsible for pinpointing around half of the FRBs tracked back to the source thus far, and is currently the best tool astronomy have to be able to do this. This will soon change, however, with what will be 2 largest radio telescopes in the world currently under construction in Australia and South America. When the square kilometre, that's what it says, South America. I wonder if that should be South Africa. Hey, well, I'll continue on. And because the other part of the square kilometre array is, of course, in Africa. They say South America here. I'm not sure if that's a typo. Anyway, continuing on. With the square kilometre arrays, telescopes come online, they should allow astronomers to track more distance and thus more ancient FRBs than even this record breaker. Also in the future, the extremely large telescope, ELT, currently being developed in North Chile, will be used to hone in on the source of detected FRBs. While we still don't know what causes these massive bursts of energy, the paper confirms that fast radio bursts, are common events in the cosmos, and that we will be able to use them to detect matter between galaxies and better understand the structure of the universe. The team's research was published in the journal Science on Thursday, October 19, if you wish to look that one up. You're tuned to ASV Radio. This is VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria. And it's 29 to 11. Let's see what this next article is. G'day, Craig. There's an email from Craig. Good evening, Clint. Great signals tonight. Cape clear, Western Victoria. Yep. Heavy cloud cover. Yeah, I know. That's a cool change coming. No good for us optical astronomers. Okay. Oh, yes. All right. Now, this is relatively short. Courtesy of ScienceAlert.com. A mysterious singing plasma waves detected around Mercury. This was interesting. 16th of October 2023. Oh, there's an artist's impression here. I've got to show you this artist's impression. Well, once again, I haven't moved it across to vMix. I can't see it. Oh no, there it is. It's right in front of me. Oh my God. I've got my glasses on too. Okay, there it is. And, oh yeah, that's it. Yep. Sorry about that. Okay, so this article is mysterious singing plasma waves detected around Mercury. Around planets that have a magnetosphere, something magical happens. If you listen with the right instruments, you can hear chirping and whistling, almost like the singing of birds at dawn and dusk. The so-called chorus waves have been recorded at Earth and Jupiter and Saturn, and observed Uranus and on Neptune. Now led by astronomer Mitsunori Ozaki of Kanazawa University, scientists from Japan and France have detected them whistling around Mercury, barren and alone as it skirts the Sun. This is interesting because those other planets have a few things that Mercury does not. Thick, lush atmospheres and permanent radiation belts where solar particles become trapped in the planet's magnetic field. Scientists say it's a discovery that could shed some light on magnetic environment around Mercury, and how planetary magnetic fields in general are shaped by the solar wind. Mercury doesn't have much of a magnetic field. It's a fairly bare chunk of rock with a particularly non-existent atmosphere. Too close to the Sun for comfort, it's constantly buffeted by radiation and the solar wind too. But this spare, exaggerated world is harbouring secrets. And oh yes, just this year, scientists finally discovered that Mercury, even with its pitiful magnetic field and atmosphere, has auroras of its own strange kind. Long before that discovery, though, scientists thought that Mercury might have chorus waves. These occur when energetic electrons become trapped in the planet's magnetosphere, spiraling along the magnetic field lines and generating waves in the plasma. These waves can be recorded and converted into sounds that vary depending on how and where the electrons are moving. And you can hear, for example, whistler mode waves recorded on Earth in the video below. Now I'm going to try and play this. I don't know how well it will come across on HF, but this is the sound of these whistlers that we do detect here on our planet. Let me see if I can bring that up. So, just making sure my levels are right. 1, 2, 1, 2. Yep. So there it is. We've got an instrument up at the radio astronomy lab location site. We have a whistler receiver operating up there, designed and maintained by Steve, VK3YJQ. And that does the same thing. That records the earthly whistlers. And unfortunately, because the RAS website is offline, you'd be able to listen to this in real time. So I can't point you to that at the moment, I'm sorry to say. But anyway, getting back to the article. So Mercury apparently has these whistlers as well. Mercury exploration has been sporadic and sparse, which means our understanding of its space environment is patchy. We've known about its magnetic field since Mariner 10 took observations back in the 1970s. But scientists are seeking to make up for the lack, and part of the Mercury mission launched in 2018 has an instrument called MIO, dedicated to studying the Mercurian magnetosphere. That instrument is not quite in orbit yet. The gravity of the Sun makes orbital insertion tricky, but the spacecraft has conducted flybys of Mercury in 2021 and 2022 that recorded observations of Mercury's magnetic field. And there, in the data collected by MIO, the researchers found clear evidence of whistler mode waves in the magnetosphere of Mercury. But because it's Mercury, there was something strange about them. and they only appeared in small part of Mercury's magnetosphere in a wedge known as the Dawn sector. This suggested that there is some physical mechanism either promoting chorus waves in that region or suppressing them everywhere else. The team conducted modelling and simulations and determined that the transfer of energy from electrons to magnetic waves is more efficient in the Dawn sector, leading to the generation of whistlers. Further understanding and characterization of these chorus waves is going to require more observations and more analysis. These first detections will allow the researchers to plan their investigations in detail and head for orbital insertion of MIO in 2025. To date, we still do not know whether Earth and Mercury have similar spatiotemporal properties of their electron-driven choruses, the researchers write. The present study paves the way for this challenging future investigations that will reveal how magnetized planet environments are shaped by the solar wind in our solar system, with potential exploration to exoplanets and their interactions with stellar winds. There it is. So, all excellent stuff. Alright, okay, we've got 5 minutes before I can squeeze in this Tamitha report. Let me see if I've got something short and sweet. Oh yeah. Okay. Alright, so I'll run this, but I might not finish the whole thing. A breathtaking new image capturing the most volcanic world in our solar system, October 19. And I'll bring up the picture of Io. We've got a beautiful little recent picture of Io, because we're talking about Io. The scarred and sulphurous surface of the most volcanically active body in the solar system has just appeared in a spectacular new images from the Jupiter probe Juno. The NASA spacecraft flew by Jupiter's moon Io on the 15th of October, swooping in as close as just 11,680 kilometers from the hellish surface. The new image showcases the moon's north polar region and even captured some volcanic plumes from ongoing eruptions. Given an estimated 150 or so of the 400-ish known volcanoes on Io, or Io, erupting at any given time, this is not necessarily a huge surprise, but it's pretty neat to be able to see the moon in action. And this is because what you're seeing on the screen is one of these new images of Io. Scientists are saying that these images are the best and clearest we've ever had of Io since Jupiter probe Galileo, which studied the gas giants and its moons between 1995 and 2003. Images such as these will provide Io research with plenty of scientists with plenty of analysis work for years to come. Writes Jason Perry of the University of Arizona, formerly of the Galileo mission, who processed some of the raw images. They cover Io's anti-Jovian hemisphere before going over Io's North Pole region and settling out over the satellite's sub-Jovian hemisphere. Io is a fascinating object. The innermost Jovian moon is just a little bit bigger than Earth's moon and absolutely bristling with volcanoes. Infrared images showed it's speckled with heat as molten material from below the surface surges up, creating vast lakes of lava. This is because of the hectic gravitational environment. Io's orbit around Jupiter is an eclipse, which means that the gravitational influence of Jupiter varies, changing the motion of the moon as it orbits. And the other Galilean moons, Callisto, Europa and Ganymede, all exert their own gravitational pull on Io. This creates frictional heating in the tiny moon that melts its insides, which then spew out everywhere over the surface. The effect this has is tremendous. The constant stream of sulfur dioxide gas erupting forth from Io is ripped out into Jupiter's orbit, where it forms a huge torus of plasma that gets constantly diverted and accelerated along the giant planet's magnetic field lines. When it reaches the poles, this material falls down to the Jupiter's atmosphere, interacting with the material therein to generate permanent ultraviolet aurorae, invisible to the naked eye, but the most powerful in the solar system. Io is proof that you don't gotta be big to make a mark. The new images reveal new details of the Moon's North Polar region, which has non-volcanic mountains reaching up to 6,000 meters in height. Because it's non-volcanic, it doesn't change as much over time as some of the other more active regions. I'll leave that just there, but I might just add to it though, in reference to the torus, the plasma torus created by the sulfur dioxide gas. What the article doesn't go into, and didn't really have to go into it, but because of the sulfur dioxide gas erupting from Io and accelerating along the magnetic fields of line, field lines, this effect causes a something called now I was about to say it, but it's just left me, celestron. No, it's a number of telescope. No, I can't think of it. Anyway, it generates radio bursts, is what I'm trying to say. And it's these decametric emissions from Jupiter that can be picked up in the shortwave region. I almost had it. The shortwave regions of the radio bands. There is a program you can get that predicts when these events most likely will occur. They refer to them as short bursts and long bursts, and it is all caused by this torus of plasma that is accelerated along the planet's magnetic fields of lines. And I just can't think of it. It's just there what the term is for that, the technical terms. So now I can't think of it. It's there, but I just can't think of it. It's really annoying me. That synchrotron, something like that. Synchrotron radiation. It's something like that. Yeah. All right. Enough of that. Thanks to Science Alert for that interesting article, and Wayne, one of my regular emailers, for bringing forth that article. So excellent stuff indeed. Synchrotron. I know it's synchrotron, but there's another name for it too. Anyway, let's go across to dear old Tamitha with her latest solar report, giving me a break for the next 15 minutes, if I can find her. I think there it is. Okay, stand by for Tamitha. You're tuned to ASV Radio, VK3 Echo Kilo Hotel, and here is good old Tamitha.
We have multiple solar storms on their way to Earth. The first couple have already hit, and yet stronger ones are to come. Those stories and more in the news this week. If you want to learn how weather from our star causes impacts at the Earth that shape the future of our world, join Professors Dr. Jenny Meehan, Michael Cook, and myself as we guide you through a space weather certificate program like no other. To enroll in the Space Weather and Environment Science program offered at Millersville University, go to millersville.edu/SWEN. It's weather for the 21st century. This forecast also sponsored in part by CW Ops. Space weather this week really begins to pick up in activity, but not so much in the way of solar flares. As we take a look at the Earth-facing disk, you can see a lot of active regions in Earth view, and you can see lots of filaments too. In fact, take a look at this filament here up in the north. You can barely see it kind of lightly lift off like that whoosh, but there is a solar storm that it launched. This solar storm's been mainly going northwest of Earth, but it does have a slight Earth-directed component. In fact, it hit just earlier today, and it's giving us just a little bit of disturbance, but that is just the first of several solar storms that we've been watching for. Take a look here now at region 3466. You can see yet another solar storm being launched. This solar storm is going mainly west of Earth, but it also have a slightly Earth-directed component. We'll talk more about these solar storms in a minute, but we're not done. Believe it or not, as we take a look at the east limb of the sun, there's quite a bit of activity there. You can see a solar storm being launched here. You'll see another solar storm being, bam, right there being launched in the south. Neither of those are Earth-directed, but keep your eye on region 3467. This one launches another solar storm right here. Ready? Wait for it. Here it comes. Bam! Right there. That solar storm actually does have an Earth-directed component, and as we take a look at it in coronagraphs, you can see it really looks like it's a partial halo. This is the one that we're expecting to come yet. It has not hit Earth yet, but it should come here in the next day or two. And that's not only the last one, believe it or not. If we take a look down here at this filament, pay attention to it and pay attention to region 3463, because on the 17th, bam, right there, do you see that thing fire? And if you watch this filament here, it begins to erode a little bit. So the combination of these two actually have sent another solar storm to the south of Earth. And as we take a look at it in coronagraphs, you can see that partial halo going south of Earth. But that means it also has an earthward directed component. So we've got a lot of solar storm models to look at. NASA and NOAA have been furiously busy, and welcome to near solar maximum, as we're going to start seeing more eruptions like this. In fact, we've already seen another one on the sun's far side, and that's going to harken new regions that will be rotating into Earth view here over the next few days, and we'll talk more about that when we get to the far side sun. Meanwhile, as we take a look at our M-flare threat meter, we have been dealing with the X-ray flux kind of creeping down a bit. We're sitting now around the seafloor, almost down below the seafloor. You can see we did pop an M-class flare back on the 14th, but that didn't last all that long. Then we popped another M-class flare along with a bit of an extended storm. This is one that launched actually one of those solar storms that's headed toward Earth. But since then, things have been reasonably calm. You haven't seen all that much activity. This means we're getting kind of quiet on the bands, and it's going to get a little bit quieter before things get loud again. So amateur radio operators definitely enjoy some dayside radio propagation with a little bit less noise on the bands than you're used to hearing. Now, switching to our solar storm conditions, well, we can see over the past couple weeks, things have been extremely quiet. In fact, we've been sitting at barely unsettled conditions to mainly quiet conditions. The only other time is when we've actually bumped up to almost storm levels here was back on the 13th, and that was due to some fast solar wind that hit us. However, it just didn't last all that long. We did get a little of aurora, but it went back down to unsettled conditions, and now it's basically down to quiet conditions. However, we are just recently gotten the impact from that first set of solar storms that's hitting Earth, and that has managed to bump us up to unsettled conditions. We're getting a little bit of aurora at high latitudes now, but not all that much, not as much as we would need to bump down to, see aurora down at mid-latitudes. But with those new solar storms coming, it should be a really good chance over the next couple days. Now, switching to our solar storm prediction model, well, this is NASA's version of the model, and you're looking down at the sun from the North Pole with Earth being off to the right. We're going to take a look at all of those solar storms that I just showed you that are on their way to Earth. In fact, this particular one, when we set this solar storm into motion here, you can see that solar storm coming out toward Earth. Bam, it hits Earth right here. The impact time really was about 6 UT on the 18th. So this is the storm that we are getting hit with right now. In fact, there's actually two solar storms that maybe are kind of back to back or on top of each other. It's kind of hard to tell from the data. But this solar storm is one of the weaker solar storms. We're not really expecting it to to cause all that much ruckus. This is the one that was going mainly northwest of Earth. However, as we take a look at yet the other solar storm, this is the one that was mainly going west of Earth. You can see it's hitting Earth basically around noon on the 18th. So again, we think that these two storms are kind of hitting back to back. It's hard to tell from the real-time satellite data whether or not in our upstream monitors whether or not both storms have hit thus far, because both of them are kind of wispy storms, very weak storms, and kind of glancing blows. So not expecting all that much. Things will likely kind of quiet down because we have to wait for the bigger solar storm, and that's what this one is. This is the NOAA's version of the solar storm prediction model. The top panel is density, the bottom panel is velocity, and you're looking down at the sun from the North Pole with Earth being off to the right. And when we set this solar storm in motion, what you're going to see here is a solar storm mainly going to the east of Earth. And this solar storm is the one that had that big halo. This is the one that was shot mainly to the east, but it was a much larger storm than the other ones we've been seeing. The impact time here looks like it's going to be about late on the 19th, and that could possibly bump us up to active conditions and give us some aurora at mid-latitudes, and that should sustain into the 20th. And then we have one more solar storm. If you recall, we have the one that's going to the south of Earth. Well, NOAA didn't model that one, NASA has, so we're back to the NASA model. And this one, as it hits Earth, you can see the impact time here is going to be about early on the 21st. So expect this one to hit after the one on the 19th, and this one could also be a decent impact for us and bring aurora down to mid-latitudes. It also means we could be storming clear until the 22nd before things really begin to calm down. So aurora photographers, if you're at high latitudes, you're going to get a show. At mid-latitudes, well, it's touch and go, but maybe, just maybe. Now, switching to our far-sighted monitor, we can no longer view the sun from the stereo A imagery because stereo A is staring at the sun from the front side. So we have to switch to what our HMI and AIA imagery of about 2 weeks ago to kind of give us an idea of what was going on the sun's far side, or what is going on the sun's far side now. And as we take a look at this, we actually are looking at regions 3451 and 3452, as well as region 3448. These regions were a bit active on the sun's far side, and in fact, when we take a look at the HMI helioseismology far-sighted viewer, we actually can see these regions that we're looking here on the gray part of this image. This is the front side of the sun, and you can see these regions as they were leaving the front side of the sun back on the 11th of October. But as we follow them, we get into the gold regions. This is the sun's far side now, and that's where these regions are. They're located on the sun's far side, and as you can see where the dark regions are here, you can see a little bit of darkness here for 3448 as well as 3451 and 52. We're definitely going to have a chance of these regions surviving their far-sighted passage. And believe it or not, as we continue watching these regions move across the disk, the far-sighted disk, we saw a huge big solar storm, far-sighted solar storm that was launched. Here is the coronagraph for this particular far-sighted solar storm launch, and this thing is almost a full halo and an intense one at that. And so it looks like, from the imagery, it looks like the location, the source region, is somewhere in this cluster of regions. So definitely be aware when regions 34, 51, 52, and 48 rotate back into Earth view in about 3 to 5 days. We're definitely going to be looking for big solar storm producers just like that, and possibly the rise in solar flare radio blackouts as well. Now, switching to our moon, we are now coming out of the new moon phase on our way to a first quarter. And by the 21st, our moon will be about 43% illuminated. So you night sky watchers, if you want to catch those dim objects in the sky, like, I don't know, maybe some aurora, well, you're going to have this somewhat bright companion to deal with. So you're going to need to check your local rise and set times. So now, switching to our solar storm conditions and aurora possibilities over the coming week, we are anticipating some more solar storms hitting Earth. We already have gotten hit by the solar storms that were supposed to arrive on the 18th. But at high latitudes, NOAA is expecting minor storm conditions and then possibly major storm conditions by the 21st, with about a 65% chance of a major storm leading into even a 50% chance of a severe storm by the 21st, that's when things should peak. So aurora photographers, if you're at high latitudes, you should definitely get a show, and then things will begin to settle down a little bit on the 22nd, but by the beginning of the work week, things should be pretty calm. Now at mid-latitudes, we're only expecting active conditions, but we do have up to about a 30% chance of a minor storm. This is at mid-latitudes that should last into the 20th or the 21st before things begin to calm down. But once again, by the time we get into the work week, things should be reasonably calm. So aurora photographers, if you're at mid-latitudes, well, if you're at the top tier of the United States, you could probably get a chance to chase. But other than that, be a little bit careful, and only if you're dedicated. Now, switching to your solar flare and dayside radio blackout outlook over the coming week, well, we have been calming down. We're sitting at about the mid-130s right now for solar flux, and this means that we do have decent radio propagation on Earth's dayside, but we also have the benefit of only having about a 5% chance of M-class flares at an R1 to R2 level radio blackout, and only about a 1% chance of an R3 level radio blackout. This means things are extremely quiet right now. It's good news for radio amateurs who want to do some decent DXing on Earth's dayside. Now, things will definitely increase as we get some of those regions that we talked about rotating back into Earth view. So expect by Sunday and into Monday, we could see that solar flare risk rise just a little bit. So radio blackouts might become a little bit more common, but it still shouldn't be too bad. You should be able to get some decent contacts and have those radio communications remain pretty open on Earth's dayside over the coming week. Now, switching to our radiation storm and polar aviation outlook over the coming week, everything is in the green. We are at the D1 normal range at the flight level 360. That's for you aviators, which is also the S0 quiet range for the rest of us. And this is wonderful news because it does mean we have very little risk for radiation storms, and these conditions will continue easily throughout this week. We just don't have a lot of big flare players on the Earth-facing disk that are all that angry right now. So luckily, these conditions should last throughout this week, possibly through next week before things calm down. And so you frequent flyers, well, you are all in the clear. So the space weather this week is actually picking up quite a bit. We have quite a few solar storms that are headed towards Earth. So aurora photographers, if you're at high latitudes, you should definitely get some decent shows. In fact, you're probably getting some already. But if you're aurora photographers at mid-latitudes, well, the best time to chase will be late on the 19th, possibly into the 20th and the 21st before things begin to calm down. And only if you're at the high tier of the United States or possibly New Zealand and Tasmania, if you guys are getting some good weather, should you really bother. Now, amateur radio operators and emergency responders, well, you guys should be getting a good radio propagation right now. Low risk for radio blackouts, and those conditions are likely going to continue throughout this week, possibly into next week. And so you're only going to be dealing with the disruptions from the solar storms that seem to continue to linger throughout this upcoming week. But by next week, things should be calming down quite a bit for you. And now you GPS users, well, things should look pretty good for you. You're dealing a little bit with radio blackouts on Earth's day side, not very much, but things near dawn and dusk might be a little bit dicey. But just be careful on the Earth's night side, because we're dealing with those solar storms, and you have to make sure you calibrate your magnetometers often if you are a drone flyer, and stay away from aurora. I'm Tamitha Skov, the Space Weather Woman. Thank you for watching.
Thank you, Tamitha. All right. 1, 2, 1, 2. Where's my audio? Yep, it seems like I'm there. 1, 2, 3, 4, 5. Yep. Okay. That was the long report from Tamitha, and she's probably going to make up. We won't hear anything from her for the next 2 weeks. But anyway, we'll see how we go. We keep an eye on her YouTube channel. So I'm glad that she sends out whenever she sends reports within a few hours. It's worthwhile putting up here for sure. Anyway, you're tuned to ASV Radio VK3EKH, and let's just finish off with what spaceweather.com might be saying. According to spaceweather.com, the solar wind is currently at a speed of 370.2 kilometers a second at a density of 12.63 protons per cubic centimeter. The disk of the sun, which I've got here, bringing it up, there it is. It's the current disk of the sun, with only, on this one anyway, at least three designated sunspots. And the current sunspot number is 39. The radio sun is 135 solar flux units, measured at a wavelength of 10.7 centimeters. And the aurora over the Antarctica, or South Pole at the moment, is looking a bit like this, for those watching the video side of things. So that was a capture I made about half an hour ago, so it's a little bit further around, but yep, there's a little bit of an auroral ring occurring there. And also within this article, they've got a report here that there's a possible CME impact. Hang on a sec, let me just bring back the camera. Okay, they say here that so the solar wind data from NOAA's Discover spacecraft suggests that a CME may have grazed the Earth's magnetic field midday in October the 18th, as Timothy was reporting. It could be the early arrival of a CME expected today, or a previously unrecognised CME taking us by surprise, they say. Either way, it sparked naked eye auroras over parts of Canada, Norway, and very faint photographic auroras over south as far as Nebraska, if you're up that way. There's also a report here about a pure sine wave in the magnetosphere. I haven't read this through, but let's see what it is. In a quiet room, you can hear a pin drop. Norwegian citizen scientist Rob Stemmens just heard a pin drop on Earth's magnetic field. It was very quiet when it happened, says Stemmens, who runs a space weather observatory in Norway. On October 17, his magnetometer was monitoring Earth's magnetic field as it does every night, and the instrument's needle had settled itself into a straight line, indicating very low geomagnetic activity. Suddenly, Earth's magnetic field began to ring, and there's a picture of this here. I'll just bring that up on the screen. There it is. Okay, this is what we're referring to. The Earth's magnetic field began to ring. A very stable 25-second magnetic oscillation appeared in my recordings, he says, and lasted for more than 20 minutes. It was fantastic to see the magnetic field swing back and forth by about 0.1 degree peak to peak. This kind of pure tone is rare, but it has happened before. Researchers call it a pulsation continuous. A pulsation continuous, or PC for short. PC waves are classified into 5 types depending on their period, and the waves that Stemmens caught fall into the category PC3. The pin dropping was a gentle gust of solar wind. Imagine blowing across a piece of paper, making it flutter with your breath. The solar wind can have a similar effect on Earth's magnetic field, and actually there's a little GIF image of this, which I can show. There it is. This is what we're referring to just now. Stemmens is a long-time observer of PC waves. Usually he catches them during solar minimum, when the room is quiet for months at a time. Recording one now so close to solar max is unexpected, he said. Lately, my magnetometer traces have been too noisy for such delicate waves, so it came as a surprise, he reckons. PC3 waves, which can only be heard in moments of quiet, can also bring the quiet to an end. The oscillations sometimes follow all the way around Earth's magnetic field and causes a tearing instability in our planet's magnetic tail. This in turn sets the stage for magnetic reconnection and geomagnetic storms. So there it is, and that's a kind of an image there of how it's happening. So I thought that I'll mention that. I thought it was worthwhile making it the very last thing to bring up. Having said that, as of 20th of October 2023, there were 2,349 potentially hazardous asteroids. And apparently there was an explosion over Melbourne the other morning, yesterday morning I think it was. Nobody seems to know what it was, but there was plenty of video footage of this massive explosion. There was a flash of light and this incredible explosion. But none of they went through a whole list of sources from the meteorology department to geoscience for seismic activity through to some other media detection group and whatever, and nobody said that there was any meteor burn or anything that was entering the atmosphere at the time. So it's a bit of a mystery as to what caused the explosion, but it wasn't recorded on film as far as visual, but its effect from cameras looking down at the ground and stuff like that, and the sound pickup was there, so we don't know what that was. Anyway, all right, that's it. At 9 past the hour, this is VK3 EKH, and happy birthday to Bill, VK3KHT. It's his birthday. So if you're still listening there, Bill, happy birthday to you, mate. And Craig was saying something too. Yeah, I don't have anything on 160 at the moment. I know that I normally simulcast on 160 for the broadcast, but there's nothing happening on 160 at this present point in time until I can get something sorted with my antennas. On that note, thank you for watching and listening tonight, everybody there. I think my YouTube stream has kept up all for the last hour or so, so I know there's a few people looking at the YouTube stream. So g'day to Don if you're over there in Adelaide, if you're watching through the stream there tonight. Well, not quite Adelaide, but in that area. I can't think of it now. Anyway, there's no. Alright, so this is VK3EKH. We shall now take a listen on 80 metres, and I'll just take my headphones off. Because I have to remove the headphones out of the radio, out of the transceiver. And let me see, getting my pen ready. Where is my pen? Okay, this is VK3CSJ, listening on 3541 kHz for any stations wishing to check in tonight. Okay, VK3JR, VK3GL, VK3SBX, and VK7JAH. Anyone else? Oh, there was a weak station there. Who was it again? Yeah, I can hear somebody calling, but there was just a sudden crash of lightning that really went over the top of you. Just try one more time. Yes, VK6 Alpha Zulu, I think it was. AZ, I got it was VK6. I think you're the regular that's been calling in. Yep, alright, I know who you are. Alright, we'll get back to you. Alright, we'll go to the top of the list and work our way through. VK3JR, g'day Frank, VK3EKH. Thanks, Frank. VK3JR, VK3EKH, and okay on the 160 missions later. No, not a problem. We turned the AR7 on last week, and we had it going through until Steve finished. So, and of course, I usually keep the AR7 running all weekend. So I'm kind of listening, doing listens mostly to noise. But it's always good to catch up. In fact, I turned the SDR on the Anand 8000. I've got the Anand 8000 finally kind of configured here, and I was listening to Steve on the Anand last week with the Spectrum running, so I thought that was quite interesting indeed. All right, I am disrupting my logbook here. I'm trying to find a call sign, and now I have lost the page that I was writing on. Oh my goodness me. I think it was Graham. Next. I think it was. Have a say, Gray, if it's you next. VK3GL in Bunyip, VK3CSEKH. Thanks, Graham. VK3GL, VK3EKH, still going through his makeshift logbook here. The problem is, it's